Okay, so let's try to understand what is a stream basically. Okay, fine. I'm putting it again. Okay, fine. One thing before going into a stream, we understand what is a function. When I say function, what is a functional interface basically? Yeah. When we define a lambda expression, what are we doing? When we use a lambda expression, what are we doing? And we are only defining a function. We are not executing it, right? Okay, and if you look at, yes, what is a function? It's something which is capable of taking some inputs and then being able to either generate some output or not even return a value, right? So it returns a value or it doesn't, right? So such a, you can think, okay, so let me come to this. Okay, fine. So if we have to look at it, it's something like this. So if I look at a function is nothing but when I say function, I'm talking about a function object of a functional interface, and we look at it as a function type. Okay, so if I have an object of a functional interface created using a lambda expression, then we are always defining, in a lambda expression we said so many inputs will be there. You're assuming some inputs will be there, and sometimes more than one, and or zero input, any number of inputs may be there, and it may have 0 or 1 output, right? So it is this kind of a box, you can think, yes, which does some processing. So you just created a box which is capable of doing a processing and generating an output, taking input and generating an output. Okay, there can be more than one inputs also, right? So it is this kind of a thing. Okay, now look at what is a stream. Okay, about a stream, what is known as a stream will always have some source from where elements will be available. Fine. When you create a stream, no processing is being done. Just like when you create a functional interface object, it is not executing the function. It is just it's like a box being created which can do processing given an element. Given the inputs, I'll then execute this and I'll give you output. Right? So it's just a box which has just been created. It's not the execution happening at all, right? Okay. Only thing what has been done is a box has been created, right? So similarly, look at a stream now. Okay. So a stream object is nothing but just look at it. Okay. So here is a object of a stream. Okay. Fine. So think of a stream object as having some source from where a stream of elements will be made available. It always has some source from where elements, it's capable of fetching elements from. Okay, and what okay, so this is a stream, right? So this is one thing, it has two parts, right? One is it is capable of fetching elements, and then what you need to do is apply an intermediate operation. We say, oh, we have two types of operations I mentioned about a stream. So if this stream, on this stream, you have to apply an operation, which is what kind of operation will have? Either an intermediate operation or a terminal operation. Fine. So let's first understand what an intermediate operation is doing for a stream. You might have noted last time, if you looked at any of the intermediate operations, what are we passing as parameter to a method which is said to be an intermediate operation? The parameter which we are passing is some kind of a function. And all of those functions which are passed as a parameter are capable of taking as input the element type, which is the type of the stream. So this is a stream. So if this is, or this is a stream of the string type. Okay, fine. If that is what this object is, then this means that this one, fine, the input to this will be some kind of the inputs elements are of type string. Okay, I've just taken as an example a string, right? And fine, on this, when we have to apply a terminal operation, we are actually passing a function object. And in these function objects which you pass here, the element which is being taken as input is of type string. Okay, if it's an intermediate operation, see, all streams, when you apply an operation, you're passing some function to it. They're saying, okay, every element which you receive, one element of the, fine, I only know about an element. So a function which takes one element as input and then it will do something. Okay, but this is what is being done. So when you are applying an intermediate operation, you are setting it up. Okay, you are setting it up, and every stream, when you apply an intermediate operation, actually creates some kind of an outlet. There is an inlet into a stream and there is an outlet to a stream. And what you have given, if it's an intermediate operation, fine, outlet if it is generating a stream. And what you are giving to it is a function, right? Okay, now many times if you want to understand, one of the methods was the intermediate operations was map. Okay, so all these functions that the intermediate operation, the function which you are passing as a parameter, okay, fine, that will be just nothing but the type of elements which come into that particular stream. Okay, apply a function and then you will have some outlet. Okay, fine. So if it's an intermediate operation, it's giving an outlet. If it's not an intermediate operation, then what? Okay, fine, we'll come to that. But so what is being done is we are connecting basically a number of functions together. Another stream, fine, this goes as inlet. Okay, maybe you are going to give some other kind of a function here. Okay, and then you get an outlet because it's an intermediate operation which you perform. And if you are performing a terminal operation, let's say, here is, you'll always be passing a function whose input type is this input. Okay, fine, that is what you should have noted when we have seen all the intermediate operations or any other operation. Even if it's a terminal operation, fine, you are passing some function, fine, where the input is going to be of the same type as the type of the stream. Fine, want to check this aspect? Okay, now let me also explain one more point here. So when we put a terminal operation, it is at this point, fine, that because this is a terminal operation, it's not resulting in some outlet, fine. Okay, it's not resulting in some outlet. That means it has to give some value from it. Okay, either give a value or maybe return type may be void. The terminal operation is either having a stream, fine, that was an intermediate operation. That means it is now generating one more outlet. Okay, or it is not a stream type. If it is not a stream type, then either returns void or returns some object. Okay, so whatever, now it has to return the object or whatever it is. So it is that type that it will try to pull from the previous things in the stream. So it is now because now there is someone who needs the result. Okay, so all these what you have done is you have built a pipeline. We call this as a pipeline. So in the pipeline, I have operation 1. Okay, this is my intermediate. I have one operation, I have put another operation. Okay, and this is my terminal operation. Now, one more thing, what happens? Why it has to delay all this? You cannot operate and have an outlet where you don't know what is going to happen to it. And that's one thing. Okay, so no execution happens till a terminal operation is applied on a stream. Intermediate applied on a stream is you're adding one more box into it. Okay, which is, in which you will have some kind of a function added to it, some functionality to be done. Okay, fine. Okay, fine. So now if you look at it, it's now one more thing. When we apply the terminal operation at that time, there is something more which happens here. Because it has delayed, it has not done any execution still. What it does is it looks at the entire set of intermediate operations, looks at the whole pipeline and optimizes this operation. It's looked at as if it's one thing to be done. Okay, and it will check where it is possible to optimize. When I combine these two together, okay, or these 3, 4, whatever intermediate operations are there, if I combine them together, is there a scope for optimization? Wherever there is a scope for optimization, it will do any kind of optimization which is available. Okay, so one thing to notice, a delayed operation, fine, it's fine, late execution is late, in the sense only when a terminal is given the execution begins. Clear? So we say intermediate operations help to build the pipeline. A terminal operation will execute the whole pipeline. Okay. Fine. Now we'll do some example, I think. Some simple example also. Last time I was mentioning about maybe we want to process a file. Okay. Fine. We want to process a file for finding out maybe all the distinct words which are there in the file. So it's a text file, let's say, as an input. And we were interested in getting a list of all the distinct words, and not all words, but yes, distinct words means, okay, no repetitions. Fine. Okay, so let's see how we can do this. Any questions? Yeah. Does this clarify further, like about the stream, understanding stream, because it's a new way of doing it, right? And this is a functional way of working basically, because you are using functional objects. What you are giving is, okay, what to do with each and every limit, right, which is coming through the stream. There's always an input, and if it's a another stream being generated, okay, that means it has taken the output from here as input. Okay, and again making available some other kind of a, it has an outlet, you can say. Stream has an outlet. It has an inlet and an outlet. Inlet is initially there is some source, fine, or if it's another intermediate operation, inlet is the previous stream on which this method was called to create a new stream. Okay, fine. Sometimes you may not be passing a function directly, but yes, there is something which is being done. For example, a method like distinct, what it is doing, you don't pass a function object, but it is known what it will do. There is an inlet and outlet, right? Inlet is all the elements, outlet will be restricted elements. Okay, fine. It has to just think about, okay, what I'll be giving in the outlet. Okay, inlet is anyway the type of elements it receives in the inlet are the previous stream. Any intermediate operation, any stream object, if you have, it either is connected to some source, or the source is the source for a stream is either some kind of a data structure, or maybe some starting point which you might have taken, or it might be a stream created earlier. Some stream has to be there. Okay, they process some kind of an element. That's fine. So stream work on some kind of an element. Fine. But they will work fine. So it is like setting up a processing unit, right? With okay, this is the first processing, next processing, next processing. Okay. Fine.
You must have one terminal operation.
But terminal, as soon as you put a terminal operation, it executes. Then it will pull from the source, and the entire pipeline has to execute now. And no execution, it's only setting up. Okay, and you actually connect those functions basically, right? Okay, fine. So with this in mind, fine, we can go to the fine. Let's look at the terminal of the intermediate operations again. Want to look at it again from this point of view again? Okay, fine. We had done it last time, so we can have a look at it. Okay, I want to list them again. Yeah. Yeah, can you remember those intermediate operations? Fine. I'm not looking at again how to create a new stream from a source. Find some kind of a source from which becomes a starting point. And for example, we had the generate, iterate, fine, off method, creating from array, and many places in the API. There was also a method called lines, which was for reading from a file and making each line available as a string. So that becomes my element. Okay, fine. So what were the intermediate operations? Fine. So, and I'm not repeating that. Okay. Yeah. So what were the other? So we are. Which are the intermediate operations? Yes. Let's have a look at the methods. We had okay. When we looked at them, we categorized them into those which may have a possibility of reducing the number of elements. Some elements may get dropped. Fine, even element transformation may be taking place, but fine. Okay, so yeah, what are those where the reduction can happen? So we are looking at methods on a stream of some type T. Okay, fine. So T is my element type. Okay, fine. So the source, right, the input side for the stream is of type T, the elements which will come in the input. Okay, so yeah, what do we do? So before it goes in the output side, we can keep the same type, right? And you can say, okay, what goes in the output side can be tested for some condition, right? So we have a method called to return a stream because I have an outlet now. Okay, stream will be of the same type. Okay, name of the method is filter. And what's the parameter? My input is going to be of type and return a boolean, true, false. Okay, fine. T, basically the signature would have been like this, extends T. Okay, but anyway, for simplicity's sake, I'm not to, and we can skip this part, but you can understand, yes, the requirement is T. So the function, it's just set up a function which will do the testing before for anything to qualify for the outlet. Right? So anything where the elements which will be pushed into this stream, they will be tested with this, and those which return true here, only those elements will go in the outlet. Yeah. Okay. What else was there? Yeah. Intermediate operations, that means they'll be returning a stream. Yeah. What were the other methods? Stream will be of the same type when we are having these kind of methods where reduction is happening. Yeah. We have the method called, oh, that's keeping the same elements, reduction. Skip. So number of elements to skip. And so we are not passing a function, but yes, here it's like on the, okay, so initial so many elements from the input, don't pass them on, right? Okay, right, so it's on the, so it's just reducing fine by the size. Yeah, what other was there? Public stream of type T, drop while. So when we say while, it talks about a condition, right? So parameter will be a predicate. It will be predicate of the same type as the type of the stream elements. Okay. So see, now it is a while. So what it means? Fine. So every element which is coming in the input, test it with this. Okay. So if it is passing the test, don't pass it to the outlet. As soon as you come across the first element where the test fails, okay, then that element and onwards, don't test after that. Every element should go from that point onwards. Okay. Fine, clear? It is drop while. So keep on dropping. Don't drop means don't pass them. Okay, keep on dropping if this condition is true. As soon as this fails, the first test where it fails, then pass it on. Then don't test after that. Okay, it's not going to test every element. Fine. That is what is the difference with the filter, because filter was also taking a predicate. Okay, fine. Then what else? Another method was based on the limit, and so that's based on the size. That means in the outlet, I won't let more than so many elements. Up to this point, so many elements. So if someone has a limit 100, if you are processing only 50 elements, there's no problem. Fine. All of them will go. Fine. But if you are only if you are receiving more than 100 elements, as soon as 100 size is reached, fine, it stops sending any further. And no more elements. It's like the end of the stream. Okay. Fine. On similar line, but based on a condition, take while. So what it does, when the first element in the input and onwards, it will keep on testing. If it is passing this test, pass on. As soon as it fails, don't take any input further. It's not going to test every element. Filter is testing every element. That's the difference between drop while, take while, and filter. Drop while, take while, they stop. Okay. That one stops dropping and this one stops passing. Okay. And so not for every element, whereas filter is for every element. Every element will be tested. Okay. Fine. Another method was we had this method called distinct, right? Clear, these were the intermediate operations which were resulting in reduction of elements, possibly reduction of elements, right? Okay, I think this was the list for in this category, reduction, keeping the same elements, right? Okay. When this was a reduction, now we'll have which keeps the same elements. Yeah, the most commonly found here, stream of T. Oh, may not be a stream of T now. Stream of type U. So when I say it's returning stream of U, I'll have to use U as a type parameter. Okay. What's the method? Map. And what's the function? It needs a function which will take element t. So given one element, for that a corresponding element of type u is what is being returned by the function. This is the mapper function. So you have told, okay, if one element of type t is coming, it needs to be transformed into u like this. So that's a function which you are passing. Okay, it's like, okay, now my outlet has elements of type u. Here map is like this. Here you are giving the conversion function. Okay, same way you will get a int stream. Okay, map to int. Okay, so when I say map to int, what is my output type? It's returning the outlet side is elements of type int, and therefore what I should, my input is t, right? So I will have to int function for t. Input is t, returns int, that kind of a function. Yeah, this is the mapper. So just similarly we have the long stream or a double stream being created for us. Map to long, map to double. This will be the to long function, and this will be the to double function. Fine. Okay. Fine. There were other some more intermediate operations where the elements would remain same, one to one basically. And one element in the input, one element in the output. Yeah. Okay. They don't, these map methods, they change the type. They are capable of changing the type. Input and output type is different. There are others which keep it same type. And for example, we have a method called to return a stream of the same type. Yeah, stream of t. Okay, method is make it sorted. Fine. We have a method which returns a stream of t. Keep it sorted, but so in this case, it's assuming the elements t is a comparable type. It's assumed here by the method that the t is a comparable type. Whereas here you are saying, okay, t, even if it's not comparable, fine, you need to follow the ordering specified by a comparator of t. Okay, so this is used to help to order the elements here. Okay, and that's your comparator. So sorry, not comparator. Okay, so you pass a comparator that changes the, so it is nothing but you're passing a function which is useful for sorting the elements of the type t. Yeah. There was still one more method which was keeping the same number of elements. Method name was peak, and you pass a consumer of t as a parameter. That's an action. So what is this for? And the idea is, okay, so take the object in the input and do this with the object, but then pass the same object further. Okay, fine, put it in the outlet. Okay, take this action and put it in the outlet, and it's not consuming it. Okay, fine. Then category where from one multiple can be generated. See, this is one to one. Okay, for one element, one input. Fine. Now it is one to many. Okay, fine. So yeah, stream of the type U. Okay, you have U as a parameter. Okay, method name is flat map. Parameter, a function whose input is same as the type of the stream. What the output says from this, for one element I can generate a stream of U. So what will be done? It's like going to concatenate all the streams to generate a stream. For every element, I have a stream of objects. And that's what the function is supposed to do. Given an input T, one element, I have a mechanism which can give me a stream. Of course, that stream may be empty. It's not that always one to many means. It's not that always the size will increase, but this is where it has the capability of increasing the size. It can so happen that there is an input for which the output is an empty stream. Okay, some input elements may result in an empty stream, so fine. But yes, it has a capability of increasing the size here. Here, what you are giving is function, and to create the next step. So it is generate, the outlet is of type U now, because the stream will be of type U. Okay, so that's your stream, right? That's your function. We'll call it as mapper here. Fine. Same way, you will get a return type will be the int stream. Okay, if you have the flat map to int, right? It's like a function where the input is t, but the output is the int stream. So for one element, I can generate a stream of integer values. Okay, so that's the mapper function. Fine. So similarly, yes, we have the long stream or the double stream coming out. Fine. So for each element, if I can generate a stream of int, yes, then it's an int stream. So this basically what is returned is a concatenation of all the int streams. Okay. This is nothing but concatenation of int streams which were generated for each while processing each element. Okay. It processes one element and receives a int stream for it. So this is the return stream is a concatenation of all such streams. Okay, fine. Now I'll add a couple of a few more streams which are keeping the same elements. Okay, fine. Those are actually inherited from the base stream. There is this stream of T skipping the same type. Okay, we have kinds of stream as sequential or parallel. Fine. So call sequential, it will become a sequential stream. Call parallel and it will become a parallel stream. Fine. Okay. Fine. So these were the intermediate operations. Okay. Fine. To get some action, to get something to work, well, these are just building the pipeline, but nothing happens. Want to see some processing to happen, we'll need a terminal operation. Okay. So let's look at the terminal operations. Okay. So if you look at the terminal operations, yes, which are the terminal operations on a stream of T? So yes, we have a stream of T. What are the operations? Terminal operations. So I think I just mentioned about 3 of them, right? Okay. Which are the terminal operations which I mentioned? They will take a predicate as a parameter. So these all 3 methods which I am mentioning currently, they return a Boolean value. Name of the method is all match. Parameter, sorry, parameter is a predicate of T. So what this one does? Okay, fine. Every element which is coming in the input, it will pass the test. If any one of them fail, I'll return a false. Otherwise, fine. So if everyone passes, I'll return a true. Clear? Okay. And same way, we have other methods with the same Boolean type. Okay, 2 more. All match, any match. It's like the ORing part. Okay. Okay. And we have another one called none match. I think the names make it clear what they are. Okay. Then the test will be used with everyone, right? When it says any match, the test ends as soon as the first element returns a true. Okay. But the first and the last one, they have to test every element. Yeah. Okay. So this is return Boolean, right? From the entire all inputs, yes, we may return a Boolean. What else would you like to do with this? Elements in the stream. Okay. So other could be statistical things. So we have method returning long, name of the methods. Just count them. Okay. Or other could be saying, okay, give me and now this one because your stream may be empty. Fine. This one says optional of T. You may or may not have the element when you ask for the min, because if it is empty, then it is optional which is empty. If the stream is empty, this is empty. Optional can be empty, we know that, right? Okay. So here, what's the parameter? If you want to find min or max, it's about comparison, right? Only then we can determine min or max, and therefore what we need to pass is a logic for comparison, which is in a comparator. Okay. Min and the max. Parameter is a comparator. Fine. So count min max. Okay. Yeah. What else? Now some maybe you would like to do get me one element from this. Oh, fetch me the first element. Right. See, one thing, your stream may or may not be ordered. Right. Accordingly, we have different types of methods. We have a method called find. One is a method called find first. Okay. Do I need a parameter unless I find first? First element from the string is to be returned. That's it. Okay, oh, what should it return? It's a stream of type T. So what is the return when I say find first? It should be optional of T. And if the stream is empty, then always that case has to be there. It could be empty stream. There are no elements. So if someone says find first, empty. And same way, you'll have an optional. Okay. Now these two methods, depending on what type of stream it is, you may use it, right? So this is saying find any. Because it's not ordered, it has to just say find any. Okay. So finding something, right? Then what else? Elements in the stream, what would you like to do with them? Process all of them? Return type void and method name is for each ordered parameter consumer of the elements of type T. Okay, so take this action and end it. That's it. Okay, when just process all the elements, you can say for each ordered in case it's an ordered stream, or just say for each. Okay, so both methods are there. Fine. Find one for ordered, other for unordered. Okay. Okay. Another thing is whatever is there in the stream, maybe give it to me in the form of a array. Okay, just collect them and give me an array for it. So again, two methods, overloaded form. So one will give you an object array. Method name is toArray. And another one, when it takes as parameter, okay, we can say array of some type A, let's say. Okay, it's a stream of T, though, fine, but it says yes to return an array of type A. And method name is toArray, but parameter is int function of array. So that's a array creator. Okay, it's an array creator. See, what is this int function of array? Input is int, returns array. This similar method we discussed with the method added in the collection. ToArray method was added as a default method in the collection. Okay, fine. So what's happening here is input is a int, right? We normally can do like this. If I have a stream of account, right? Let's say. Okay. And what I can do is I can say account array. Okay. Accounts, maybe that's a variable name I use, equal to SA dot. It's a stream already, right? So stream of account dot. What's the terminal operation I'll apply on this? ToArray. What's the parameter? Yeah, what's the parameter here? See, this is our constructor reference where we have a input as a int, right? This is equivalent of, right, that method reference which I have written is equivalent of saying given a size, okay, return a new account array with that size. And okay, so converting to an array. Yeah. Okay, so and these are, I think, the most common terminal operations. Oh, there's one more. And of course there are those advanced. Right? This one says you can just like you can get an array, why not we get a list of t? We can get a list of t. Method name is toList. No parameters. Returns a list. So whatever you have done, all that pipeline, but the end, whatever is in the outlet, just put it in a list and give it to me. The list returned here is unmodifiable list. Okay. Okay, it's an unmodifiable list which is returned. And clear the terminal operations.